Hey, all you cool cats and kittens. I crack myself. I'm sorry. I've been wanting to say that. Happy Wednesday. It's April 15th. Well, would have been tax day, but it's not now. I wanted to do some examples of the Pythagorean Theorem application problems with you, and I know how much we all love application problems. So yeah, that's what we're going to do this morning. Your assignment for today is the same as it was yesterday. You're working on 7.3 Part A, Practice B assignment. If you get done and you want to go ahead, you can go ahead and do the quiz if you feel confident. If you want to redo one or both, reach out to me and I will reassign it for you. I have a couple of Pinterest posts before we get started. I know you're not old enough to do this, but boy, when you get old enough, this is so funny. I'm redoing the deck, so I went to Party City and purchased a skeleton. Now in 20 years, when the new homeowner needs to redo the deck, I love that one. You said 2020 was going to be like a movie? Yeah, Home Alone. And I love Baby Yoda, so cute. Those that call it the coronavirus, those that call it COVID-19, and those that just call it the Rona. Thug life, that's cute. I love it. Well, Baby Yoda's adorable. Okay, so like I was saying, I have got some super fun application problems for you today. It's going to be really cool. These are problems where you're actually using the Pythagorean theorem to solve either a word problem or a story problem or an application problem like this one. Here, and this is my version of the Pythagorean theorem. It's really a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. But I like to think of it more as leg squared plus the other leg squared equals the hypotenuse squared. That makes more sense for me. So over here in this example, this is clearly our right angle right here, okay? You can kind of see that. It looks like a right angle, right? Seriously? Come on, pen, over here. Oh, I turned it off. There we go. This looks like a right angle here, right? So we'll put the little right angle thing here, which means that this side and this side are our legs. Okay, so what we've got is it doesn't matter which one is A or which one is B, okay? Just they both have to be the legs. So we've got 2 squared plus 1.5 squared equals the distance from James's house to Sarah's house, which is clearly the side we don't know. Okay. Well, 2 squared is 4. 1.5 squared, I went ahead and did that in advance. It's 2.25. equals c squared, right? When we add these two together, we get 6.25 equals c squared. Our last step is always to take the square root of both sides. So we do the square root of 6.25 and the square root of c squared. And surprisingly enough, this is not irrational. You get 2.5. How cool is that? So this distance over here is 2.5. I didn't even have to round that. That's just how it came. All right, so that's one example of how to use this. Let's see if I can get the next page. There we go. All righty, I'm going to change the frame on this so I can, no, maybe not. All right, so here we have your typical house and ladder problem, okay? They like to do these a lot. The thing that's different in this case is here's our right angle right here. What we're missing is a leg, all right? The thing we don't know is a leg this time. We have this leg, we're missing a leg, and we've got the hypotenuse. So what you do is you go ahead and fill in what you know, okay? I know one leg is 5, so we'll do 5 squared. The other leg, I don't know what it is. So I'm just going to use one of the letters, A or B, doesn't matter which one. And then the hypotenuse is 10 squared, okay? So go ahead and square these two numbers. That gives me 25 plus B squared equals 100. And now we just want to solve for B. So in order to solve for B, we have to get B by itself. What we do is we subtract 25 from both sides, and that at least gets b squared by itself. That's 75. Okay. Now I need the square root. My last step is always the square root. And the square root of 75 is an irrational number. It's a very long number. 8.66025, and it just keeps going. Let's say we want to write that answer to the nearest tenth. Well, we would do 8 point, and now do we leave this a 6 or do we make it a 7? You don't ever go smaller. You either leave it the way it is or make it one more. Well, you look at the number to the right of it. If it's 5 or greater, then we make this number one more. 6 is greater than 5, so we're going to make that a 7. That's an estimated answer. Okay. Are you having fun yet? I love this. Oh, yeah. I thought this one was kind of cute. It didn't give you the whole drawing. It makes you work for it a little bit. You're locked out of your house, and the only open window is on the second floor, 20 feet above the ground. Okay, so let's imagine that we've got some window up here that's 20 feet above the ground. Okay, so that tells us this distance here is 20 feet. It's kind of messy. You need to borrow a ladder from one of your neighbors, but there's a bush. Is that your special bush? There we go. There's a bush. And you're going to have to place the ladder 15 feet from the base of the house. So we know this distance is going to be 15 feet. How long of a ladder do you need? Well, this is our right angle here. And so these are both legs. 20 and 15 are both legs. So we do leg squared plus the other leg squared equals the side we're trying to find squared. 20 squared is 400. 15 squared is 225 equals c squared. 400 plus 225 is 625. And then we take the square root of both sides. And isn't this interesting? Not an irrational number. 625 is a perfect square. I didn't see that coming. But you're going to need a 25-foot ladder. Okay. Alrighty, what beautiful problem do I have next? Oh, it's a cone. A lot of times they like to throw these in here, and this one has a twist. Okay. This one, they've given you that this is a right angle here. Okay. And they've told you that the diameter all the way across is 8 feet. And that the height is 9 feet. And they want to know, this is called a slant height, by the way. Sometimes you'll be asked for the slant height. It's good to know that that is what that is. It's the slant height, all right? Well, this is not 8. The whole way across is 8. This is half of 8, so this is 4, okay? So our two legs are 9 and 4. So leg squared plus the other leg squared equals our hypotenuse, or our slant height. 9 squared is 81. 4 squared is 16. Add 81 and 16 together, and you get 97. And then we do that last step. We take the square root of both sides, and we get C is, oh, this is a hideous one, 9.848857, and it keeps on going. Well, to round this to the nearest tenth, we want to either keep this an 8 or make it one more. We need to keep the 9 too. Now we look to the number to the right of it. Because it's a 4, that's a round down. 0 to 4 is round down, and we don't make it less, we just leave it the same. So our slant height is approximately 9.8 feet. If you weren't having fun yet, here's what it looks like in a word problem. I have Riley sits 7 feet directly behind Lily. Alyssa sits exactly 4 feet to the left of Riley. What is the distance between Lily and Alyssa? All right, so I've made these little letters here to represent these 3 girls. Riley sits 7 feet directly behind Lily. So if Lily's in the front of the room and Riley is 7 feet behind her, we can put her here. Now we know Alyssa sits 4 feet to the left of Riley, so she's to the left of Riley. All right. So what we have here is we have a triangle. I'll draw it. It's probably going to be bad, but I'll draw it. You guys are used to this. I drew badly on the Promethean board too. All right, so Oh, yeah. Okay. Boom and boom. This is our, I should have just used the line drawer. That's terrible. This is our right angle because Riley is directly behind Lily and Alyssa is directly to her left. Don't look at the lines. So these are our legs here, and we know that this distance is 7 feet, and this distance is 4 feet, and we're trying to figure out what's the distance between Lily and Alyssa. So we have our two legs, leg squared plus the other leg squared equals c squared, or the distance between Lily and Alyssa. So this gives us 49 plus 16 equals c squared. 65 equals c squared. And now we have to do the square root because it's unlikely that Lily and Alyssa are 65 feet apart. That's crazy. We take the square root of both. And this one also was a non-terminating decimal, 0.6225 and so on. So we're going to say that Lily and Alyssa are 8 point, do we leave it 0 or make it a 1? Well, this is a 6. And because 6 is 5 or greater, we make it a 1. We make it 1 more. And that is much more reasonable. Lily and Alyssa are 8.1 feet apart. Okay. So application problems are really how you can have fun with the Pythagorean Theorem. And we have some wonderful application problems for you over on Edulastic. You should just hop over there and get those assignments done. I know you're going to have a great time with them. See you tomorrow.